In our previous class, so what is that we had in our previous class is Ampere's law. Actually, we have done Ampere's law. Comfortably, we have finished the Ampere's law concept. Concept only. Actually, we are going for an applications of the Ampere's law. The first starts with a solenoid. So what is that you are seeing in this picture is a solenoid. This exactly is a solenoid. Can see it's closely wound copper wire. You can see that. Basically, it shows magnetic field or magnetic field energy. You can see that in this, if the gapping is large, for example, gapping is close, gapping is large. This is how the field lines are. You can see the field lines actually. The picture, what is that you are seeing is a field lines. The magnetic field due to a section, a small portion of the solenoid. You can see that field lines. It is a finite solenoid. This one is a long solenoid. Almost for practical purposes, we will take a long solenoid only. When I say long solenoid, I will use a word called number of turns per unit length. That is described by n is small n is equal to capital N by L. Right. Now you take an arrangement like this. Actually, we are taking a principal section. Imagine a cylinder, you cut exactly into half. So, are not physically. Imagine. So, in one side, you will say an inward, all this current flows inwards, all this portion current flows outwards. Till this point, any doubt? Now I am taking one such element over here. One element. I am taking this point P as my reference point, where I would like to determine the magnetic field. Remember, this line is the axis of the solenoid. I am taking a small element over here. The element is of length dx. Remember, this element makes an angle theta at P. And this point P is at a distance x from the center of the. In fact, this behaves like a ring of n dx turns. Any doubt till this point? Right. Now the question is, what you wish to express? I will take this entire portion as a ring. We already know the formula. Field along the axis of a circular coil. What is the formula? Mu naught by 4 pi 2I pi r square by x square plus r square all to the power of 3 by 2. But this is for a loop. The entire formula is for a loop. But we know that there are some terms. And that terms are small n by L times dx. Just now I told you, no, n dx terms. Okay, right. Now you take, you see, this is R, this is R, this is X, and this triangle R by X is tan theta. So R is X tan theta. You can write X as R cot theta. Dx becomes minus R cosecant square theta. Any doubt till this point? Now X square plus R square is R square cosecant square theta. Now you use this entire data in this equation. This will allow you dB is equal to mu naught by 4 pi 2 into I into pi r square by r cube cosecant cube theta n by cosecant cube. And I'm saying, see, practically I'm substituting all whatever the data that I had. This allows me finally mu naught I r 2 pi 2 mu naught by 2 I n. Okay, right. N by L I am representing as n. So what is finally left? Minus sin theta d theta. And now remember this element here which you have starts from here, which makes an angle theta 1. And it ends here with this line, it makes an angle theta 2. Don't measure this as theta 2, wrong. When you are taking a reference as this direction, with respect to this theta 1, with respect to this theta 2. Any doubt till this point? I have substituted that here. You know what I got? Mu naught Ni by 2 times cos theta 1 minus cos theta 2. Any doubt till this point? So what is the magnetic field formula? Mu naught Ni by 2 cos theta 1 minus cos theta 2. If you plot a graph taking field along y-axis, distance x along with respect to p, you will get the graph like this. Remember, some region field is uniform. Inside, if it is a long solenoid, some region it is almost uniform. Thereafter, when it comes to the ends, it falls. For example, if at the center field is mu naught Na, at the ends it will be half of that. I am not cheating, man. See, at the end you take, what will happen? One will become 90, the other will become 0 nearly. It is a long solenoid. And thereafter it falls down to 0. Therefore, infinite long means you will use almost theta 1 as 0, theta 2 as pi. Infinite long means ante kada. Therefore, mu naught Na. How to find the direction of the magnetic field? Simple. Again, use right hand grip rule. If the right hand grip, curl of the four fingers represents the direction of flow of current, thumb represents the direction of the magnetic field. నిన్న నువ్వు వచ్చావా? షూర్? షూర్ వాడు నువ్వు రాలేదు కదా నిన్న? ఎందుకు రాలా? అన్న సీరియస్గా ఉండాలి. సెకండ్ ఇయర్ క్లాస్ అని వినలేదుగా. ఇంకేం అర్థం అవుతుంది నీకు? అప్పుడు సినిమా చూడటానికి వచ్చినట్టు వచ్చావు నువ్వు. నెక్స్ట్ రైట్, నువ్వు లెసన్ విన్నానని చెప్పావు. రైట్, మీలో కూడా ఎవరో ఆబ్సెంట్ అయినట్టున్నారు. ఒక అమ్మాయి ఎవరో, అంతేనా? అందరూ వచ్చారా? అనిత కదా నీ పేరు? కొంచెం టైం పడుతుందా? గీతిక. రైట్, గట్టిగా చెప్తూ ఉండాలి, అప్పుడు బాగా గుర్తుంటుంది. రైట్, ఇక్కడ దాకా ఓకేనా మీకు? నాకు కావాల్సింది రెండు ఫార్ములాస్ అయ్యింది. ఫీల్డ్ ఇన్సైడ్ లాంగ్ సాలినాయిడ్ mu naught Ni. ఒకవేళ ఎండ్ తీసుకుంటే mu naught N/2. ఇన్ బిట్వీన్ తీసుకుంటే కాస్ థీటా 1 మైనస్ కాస్ థీటా 2 టర్మ్స్లో ఎక్స్ప్రెస్ చేయాలి. ఎనీ డౌట్ టిల్ దిస్ పాయింట్? రైట్, ఇది కొంచెం అంత మునిపే చెప్పు ఉండాల్సిందే, బట్ స్టిల్ ఓకే, నో ఇష్యూస్. ఇది చాలా స్పెసిఫిక్ అనమాట. హెల్మ్హోల్ట్జ్ కాయిల్స్ అని, ఇది చాలా అంటే యూనిఫార్మ్ మ్యాగ్నెటిక్ ఫీల్డ్ ప్రొడ్యూస్ చేయటానికి దీన్ని యూజ్ చేస్తారు. వాట్ ఆర్ హెల్మ్హోల్ట్జ్ కాయిల్స్? బేసికల్లీ two identical coils carrying the same number of turns, carrying the same current in the same sense, basically. Now, what is happening? Forget about coil 2. In the absence of coil 2, this is the graph for magnetic field. In the absence of coil 1, this will be the graph for coil 2. When both are present, almost in between this region, the field will be uniform. And అందులో కూడా వాడు ఎంత తీసుకుంటారంటే బాగా గుర్తుపెట్టుకోవాలి హెల్మ్హోల్ట్జ్ కాయిల్ కండిషన్ radius r separated by a distance r. Each coil is of radius r, each coil have the same number of turns and they are separated by a distance r. మీరు కనుక చూసుకున్నట్లయితే బి హెల్మ్హోల్ట్జ్ ఏం కావాలి 2 times r/b at x is equal to r/2. మామూలు మన ఫార్ములా ఏంటి μ0 అరేలేరా పైన 2π కింద కొడేసాడు మామూలుగా అయితే మనం μ0/4π i 2π రాస్తాం కదా μ0/2 ni r² plus x² whole power 3/2. Now substitute x is equal to r/2 here. After substituting, you will get this relation. Remember, this is uniform magnetic field. Remember, in laboratory, I usually tell you an inward magnetic field, constant inward magnetic field, a constant. Where will you get that, man? This one. You know, in our, suppose any accident happens, particularly for a brain and all that, doctor advises us to take one scan. What is that? That also involves the same thing, same arrangement. And again, they won't allow metals and all that. They won't allow metals and all that. Right. So this is the purpose of Helmholtz coil is to produce uniform magnetic field in the laboratory. Right. This is a very special question in galaxy. And remember, every time you will get this question. See, why I have pasted some questions and why I am doing some questions, you need to understand. In a minimum time, to cover maximum content, I am using this. Yesterday, because of that pasting and all that, I wasted some time. Right. Chalo. Everyone try to read the question carefully. Sanjana reading. Suppose if I'm teaching any additional questions, just make some provision in your notes only. Write it. Maximum I will cover the same questions. You can see a thin conducting strip of width h is highly wound in the shape of a very long cylindrical coil with cross-sectional radius r to make a direct current I flows. Remember, it's not a wire, it's a strip. అరే మీరు షటిల్ బ్యాట్కి గ్రిప్ వేయించేటప్పుడు ఇట్లాంటిదే వేస్తారు గుర్తుందా మనకి పేగడమే గుర్తుంది కానీ వెయిట్ సాత కాదు కదా కాబట్టి షటిల్ బ్యాట్ గ్రిప్ that is how you have I flows through the strip. Find the magnetic induction inside and outside the solenoid. Remember, this solenoid is different from the solenoid just now I have previously informed. It is a single wire previously. And that is closely wound. There is no gap. Almost field lines are straight horizontal along the axis. This is a different one. Sir, in what way it is different? I'll explain. If you allow me, I can use the word current per unit length. Any doubts? Right. Current per unit width actually. Because you mentioned here the width is h. So I am taking current per unit width. Any doubt? J is equal to I by h. This is what I have decided. అదే కరెంట్ ఎలక్ట్రిసిటీలో అయితే ఏమనేవాళ్ళు కరెంట్ పర్ యూనిట్ ఏరియా అనేవాళ్ళు హియర్ ఐఎమ్ యూజింగ్ ద వర్డ్ కరెంట్ పర్ యూనిట్ విడ్త్ రైట్ If you understand this is H, and one full rotation gives 2 pi r. అంతే కదా. See, this is H width. One full rotation is 2 pi r. అంటే for example, if someone starts here, okay, if someone starts here, if he completes one rotation, he will exactly reach us here, this point. Spiral partner, helix అంటే అంతే కదా మీరు. ఇది కదా హెలిక్స్, అవునా కదా. హెలిక్స్ కేసులో మీరేం చేస్తారు, ఒక పిచ్, దిస్ ఈజ్ వన్ పిచ్ అనుకుంటే, ఇది ఒక పిచ్ అని అనుకున్నట్లయితే ఇది 2 pi r అవుతుంది ఆ కేసులో. ఇక్కడ పిచ్ ప్లేస్లో హెచ్. ఎనీ డౌట్ టిల్ దిస్ పాయింట్? సో వేర్ ఎవర్ సైన్ తీటా, అసలు ఇది ఫస్ట్ తెలియకపోతే ఏం అర్థం కాదు కూడా మీకు. నాకు ఒక్కసారి కాన్ఫిడెంట్గా చెప్పాలి, ఇది ఫాలో అయినారా ఫాలో కాలేదా. షూర్. నౌ ద ఇష్యూ ఈస్, దిస్ ఈస్ the direction of the current. Now I will resolve this current element, the current per unit width, into two components. One component in this direction, the other component in this direction. J sin theta along the axis. J cos theta, actually I should say circulating. మన పాత అదే ఇందాక చెప్పిన సాలినాయిడ్ లాగా అయితే జే కాస్ థీటా, అంతే కదా. ఇప్పుడు కరెంటు ఇలా తిరిగే కరెంట్ జే కాస్ థీటా, ఈ డైరెక్షన్లో పోయే కరెంట్ జే సైన్ థీటా, రైట్. జే కాస్ థీటా విల్ గివ్ యూ సిమిలర్ టు ద ఫీల్డ్ ఇన్సైడ్ ఏ సాలినాయిడ్. సరే, మరి కాస్ థీటా అంటే మనకి ఇప్పుడు ఇక్కడ హెచ్, ఇది 2 pi r అంటే యూ కెన్ గెట్ కాస్ థీటా ఫ్రమ్ దిస్ ఫార్ములా. దిస్ ఈస్ కాస్ థీటా. What is the formula for field inside a solenoid? Mu naught Ni, number of turns per unit length into current. There is no turn, one turn, and per length into current is current per unit length. ఇప్పుడు ఇక్కడ ఏం లేదు రాబోయే, పాత ఫార్ములాలో ఇంటూ కరెంట్ I by L కదా, జే కాస్ థీటా. అయిపోయిందా? సో ఇప్పుడు ఇది ఓకే మీకు, ఇది ఓకే. ఇది ఎందుకు ఓకే, మీకు ఆల్రెడీ పరిచయం. మ్యూ నాట్ ఎన్ఐ నేను చేసింది. అరే ఎన్ కనిపించట్లేదని చూడకండి, వన్ టర్మ్, రైట్. మ్యూ నాట్ జే కాస్ థీటా. టిల్ దిస్ పాయింట్ ఎనీ డౌట్? ప్లీజ్ టెల్ మీ, యూ హ్యావ్ ఎనీ డౌట్ ఇన్ దిస్ పాయింట్? You will substitute. So first thing, inside you got it. At a point inside you got it. Now you are a observer here. What is that you will observe? I will observe that a current goes into at every point on the perimeter, and that current is J sin theta. Now the entire thing acts like one single current carrying conductor when you are looking from outside. Suppose if the radius is r and you are at a 2r distance from the axis, you see a single current carrying conductor carrying a current simply I. So what is the formula for magnetic field due to a current carrying, long straight current carrying conductor? Mu naught I by 2 pi r. Okay, then the other question, you should have a doubt now. Two doubts. Finds are, due to solenoid effect, you have expressed this formula. Due to straight, you have expressed this formula. Why not you did not consider anything about this one inside the solenoid? Doubt? Yes or no? I will answer this right now. See, when I see from a side view, I will see the arrangement like this. I will see the arrangement like this. All that says have inward current I. అరే నువ్వు అప్లై ఆంపియర్స్ అలా ఇన్సైడ్ some r distance. Is this loop enclosing any current? So at any point inside, B is equal to 0 due to J sin theta component. Due to J sin theta component. At any point outside, at this point, what is happening? Yes, P into 2 pi R is నువ్వు ఏదన్నా చదువు ఫైనల్లీ ఐ కరెంట్గా పోయేది దానిలో ఐ టోటల్ కరెంట్ ఈజ్ ఐ కరెంట్ పర్ యూనిట్ విడ్త్ అయితే నీకెందుకు కరెంట్ అయితే నీకెందుకు టోటల్లీ కరెంట్ ఫ్లోయింగ్ ఈజ్ ఐ దట్స్ ఇట్ కాబట్టి అవుట్ సైడ్ ఇట్ ఈస్ బి ఈజ్ ఈక్వల్ టు మ్యూ నాట్ బై 2 పై ఐ బై ఆర్. Whereas in outside solenoid, outside a long solenoid, field is 0. You may ask me how. I'll simply explain like this. The infinite long solenoid. I'm just showing you an arrangement like this. For example, this side, all the currents are into the plane of the paper. All the currents here are outward. Now I'll take that is some imaginary path. What is the net current enclosed by this path? ఎవడన్నా చెప్తాడా కొడదాం అనుకున్నా 0. So obviously 0. So integral B bar dot DL bar is 0 outside. So B outside is 0. Right. If you have another doubt, suppose you are taking this as your Amperian loop. Okay. Now, see, you know, what is the direction of the magnetic field inside? Help me. Right hand grip rule. So therefore, inside, if there exists a magnetic field, the magnetic field direction will be that is the direction. So at this point, what is the direction? At this point, the direction of magnetic field is like this. And along the AB, even though there is magnetic field, mutually perpendicular, dot product 0. Along DC, dot product 0. Along AD, there is no magnetic field. So if we apply integral B bar dot DL bar, you will get mu naught times I enclosed. B bar dot DL bar minus B, because field is in this direction, you are going in the clockwise, anti-clockwise sense. Minus B dx. What is the current enclosed? I know N stands for number of turns per unit length and into I into dx. And in fact, it is inward. So minus. Why I put minus there? Inwards. Outward current aithe plus. Right. Therefore, finally, B is mu naught Ni. So due to a solenoid, field outside is 0, field inside is mu naught Ni. Any doubt in this? Pakka? Sure? Right. So that is the reason why you need to tell. Remember, you will definitely get this question someday or other. Prepared for this. Are we clear? Pakka? Right. Next, a similar arrangement called toroid. మన బ్యాంగిల్ గట్టి బ్యాంగిల్ తీసుకొని బ్యాంగిల్ చుట్టూ వైర్ దగ్గరికి వైండింగ్ చేశారనుకోండి. లైక్ ఎ బ్యాంగిల్ యు టేక్ అండ్ యు టేక్ సమ్ క్లోజ్ వైండింగ్, you will get toroid. Okay. See, the problem with the toroid is field lines are bound within the bangle itself. Field lines are bound within the bangle itself, like this. Field lines. Now we will do one thing to determine field at a point S inside. At a point S inside. This is the point S inside. So I will take this as my Amperian loop. My Amperian loop. B into 2 pi r. B into 2 pi r. Yes, of course. This is the radius r. Is mu naught times. See, remember here N stands for total number of turns. Right. If there are total N turns, how many such dots you will get? N dots, which is equal to mu naught times Ni. So Ampere's law is applied as this is Ampere's law. B times 2 pi r is mu naught Ni. So therefore, B is mu naught by 2 pi N times I by R. This is the expression for field inside a toroid. What about field outside or I don't know, this is also outside as well as this is also outside. Wherever you take, there is no current. Why? Array, how many inward elements you will have? Same number of outward elements you will have. Net will be 0. So therefore, outside it is 0. Right. Any doubt? In only formulas are required. That's all. Nothing else. This one I have just taught you. Right. Now our problems will start. Hmm. Everyone start working on this question. Illustration 2.33. Consider a coaxial cable which consists of an inner wire of radius A. Read that. Everyone try this. This one question is a standard question which you will be questioned every time. ఏమ్మా ఏం కావాలి కానీ ఇక్కడ ఉంటాయి ఏదో తీసుకో. Okay. Now you need to understand there are three regions: region 1, region 2, region 3, region 4. Have you all understood the question clearly? Right. First, we will work on A. X less than A. In this particular case, you are here. Now, some way this is outward current. If it is an outward current, what is the direction of B here? For an outward current, what is the direction of B? Thumb outwards. Curl of the four fingers, anti-clockwise sense, tangent. Right. So what is going to be the field here? B at that point. So integral B bar dot DL bar is mu naught times I enclosed. B into 2 pi R is mu naught times I enclosed is J into current density into pi R square. What is current density, by the way? Current density is nothing but I naught by pi A square. So therefore, P into 2 pi R is mu naught I naught by pi A square times pi R square. Okay? Till this point, any doubt? Now see, if you compromise, I cannot help. So therefore, finally, B is mu naught by 2 pi A squared into I naught times R. Any doubts? Clear? Boys. Most easiest part is only this. Now you want a region between A and B. Option B. A less than X less than B. Nothing to discuss here. It's a simple substitution. B bar dot DL bar is mu naught times I. And then again the I naught otherwise. So therefore, simply B is mu naught by 2 pi I naught by R. Right. That part is done. The most difficult part is in the region between B to C. That is the most difficult part. Why, I will explain. Now you take C. What is C? Between B to C. Your problem is between BC, there is some inward current, there is some outward current. Now in between B to C, what is the current density? I naught times pi C square minus B square. Agreed? Right. Now please follow the diagram very, very carefully. You have no doubt with this portion. A carrying outward current I naught. Any doubt? Girls. Now you have ఇప్పుడు నోట్స్ చూసుకుంటే మనకు చదవాలనే ఫీల్ రావాలి. అందుకే ఏదో డెకరేషన్ అన్నట్టు చూడకూడదు. అవునాగా? రైట్. That is the region between what is that boss? It is between B to C. That is not even a worry point for me. My worry point is that's my worry point. Why? నీ పేరు మర్చిపోయా మళ్ళీ గట్టిగా చెప్తూ ఉంటే నిధి. ఈ మధ్య కొంచెం నవ్వుతున్నా, మనదా బాగా సీరియస్గా చూసేదాన్ని. రైట్. At that point, in that pink color ring, you have different current carrying conductors. Have you noted? Can you please tell me what are they? One is I naught outwards, the other is some region between C to D. Makeup required. ఇది కూడా పింక్ ఏదండి. Color, what color? That portion. Clear? So integral d bar dot dl bar is mu naught times I enclosure. Here is my major problem. I naught plus or minus a. Nidhi, plus or minus a. Minus ఎందుకు మైనస్? వెరీ గుడ్. ఇన్వర్డ్ కరెంట్ అని చెప్పి సరిపోతుంది. రైట్. అండ్ వాట్ ఈస్ దట్? బట్ అదే కాన్స్టెంట్ కాదు, మళ్ళీ అది మీరు జాగ్రత్తగా క్యాలిక్యులేట్ చేసుకోవాలి. కరెంట్ డెన్సిటీ టైమ్స్ పై ఆర్ స్క్వేర్ మైనస్ డి స్క్వేర్. దట్ ఈస్ ద కరెంట్. ఓకే. mu naught times I naught minus I naught by pi c square minus b square times r square minus b square into pi. Cancel pi. So b into 2 pi r is equal to mu naught I naught times c square minus b square minus r square plus b square by c square minus b square. Except cancelling these two, we don't have any other satisfaction. Therefore, finally, b is mu naught by 2 pi I naught by r c square minus r square by c square minus b square. After all, this is filled at a point here. Okay. Here, what else you want? X greater than C. What is the field outside this system? X greater than C. Why, Nidhi? Net current 0. जितना inside जा रहा है उतना ही बाहर आ रहा है. Whatever the current that goes in, the same current is coming out. So therefore, for D, X greater than C, I net is 0, B is 0. Remember, these are the different stages involved. Actually, if I am not mistaken, they will ask graphs also. Let me just see. Actually, earlier they used to ask graphs. Okay, no issues. Right. Graphs కూడా అడుగుతారు ఇది. I think if I'm not mistaken, the graph will be something like this. Okay. Thereafter, what is happening? In like this. Thereafter, magnitude is further reduced. ఎందుకని అటగిస్తే అటగి That's how you will have the graph. This is still surface till B. అంతేనా? అరే ఫస్ట్ బి కాదు కదరా, ఏ. That's the deal. Graph is also important. Even now, if you have any doubt, you please bring it to my notice. I will try to discuss this once again. But it is a very important model. I don't know how you will do it in the exam. They will expect all four as one multi-correct answer type question. I am still not getting into doing problems till now. Just teaching basic theory. ఇది ఫస్ట్ థియరీ కంప్లీట్ చేస్తే వీ కెన్ గో ఫర్ ప్రాక్టీస్ యాజ్ పర్ యువర్ టుడేస్ వెడ్నెస్డే కదా. నేను అసైన్మెంట్ పెట్టాను, గ్రూప్లో చూసుకున్నారంతా. నేను 2 క్లాసులు లింక్ పెట్టాను, పెట్టలేదు. ఇంకా పెట్టేదే ఉంది, మీకు మామూలుగా సబ్స్క్రైబ్ అయితే వచ్చేస్తూ ఉంటాయి కదా క్లాసెస్. నెక్స్ట్, వావ్, ఇది చూస్తే ఎలా ఉంది క్వశ్చన్? గ్రావిటీ కాదు, గాజులాలో కూడా ఇదే గాజులా బేస్డ్ క్వశ్చన్. రీడ్ ది క్వశ్చన్ కేర్ఫుల్లీ. Come on, and I'll post this question, whatever the notes that I am writing today, again back to the notes. ఖాళీలు ఉన్న చోట నోట్ చేసుకోండి. నాకు తెలిసి లాస్ట్ ఇయర్ ఇది వచ్చిందో లేదో డౌట్ నాకు. Cylindrical cavity. Long cylindrical conductor has a cylindrical cavity. Right. Cylindrical cavity. A long cylindrical conductor has a cylindrical cavity running all along its length apart from the cavity. The entire cross section has uniform current density J. Find the direction and magnitude of the magnetic field at a point P inside the cavity. It is given that the distance between the axis of the conductor and the axis of the cavity is B. No issues. How the way we solved our cavity problems in gravitation, we will do the same. This entire thing so imagine this color is representing an outward current. And here lies center C. So this plus cavity. Suppose if we are seeing an inward current throughout this conductor, you have an outward current of same density, current density. ఒరే మీకు చల్లగా ఉందని అది తగ్గించేస్తారు ఇక్కడ ఇలా ఫ్లాప్స్ ఇట్లా పైకి లేపి కూలింగ్ పెట్టండి, అప్పుడు మీకేం ఎఫెక్ట్ ఉండదు కదా. రైట్, దిస్ ఈజ్ ఈక్వల్ టు రైట్. Now this is what I am assuming. Actually, this is what given to you. C, or actually they have given this as O. This is a C. Now I'll go with the usual formula at any point inside. Now at this point, outward, and you will have magnetic field like this. B. Which is at a distance R. Current density J pi R square. Upwards. At this point, B is equal to 0. Let this be B1. Let this be B2. So at the center, you will have B1 actually if required B2, but B2 0, B net is B1 plus B2, which is nothing but mu naught J. In this case, R is the distance between them is B given. Any doubts? Are we clear? Pakka? Sure, right. Even if you ask me some other point, apart from this some other point, for example, if you ask, For example, you are asking some other point, say here. See here, which is at a distance R1 from here. Inward, boys, it's an inward field. Correct kada? What is the direction of the magnetic field line? Outwards. Now erase. Right. మీరు ఎందుకు మాట్లాడుతున్నారు? Here is the point. This is a C. At this point, here is your B1, and again here is your B2. Here B2 is not 0 now. Can you please help me in writing B2? B2 times 2 pi R1 is mu naught J pi R1 square. So B2 is mu naught J R1 by 2. Now you take the point over here. Here clearly B1 is mu naught J R by 2. B2 is mu naught J R1 by 2. B is B1 plus B2. Mu naught J R plus R1 by 2. R plus R1 is nothing but D again. So what have you understood inside the cavity? From these two results, we can conclude inside field is inside cavity. Inside cavity, field is uniform. So hereafter, if we have an arrangement like this, and if you have the cavity like this, and if we have outward current carrying conductor here, at the center, only due to the outward current carrying conductor, the field is upwards. So the field inside is uniform. Uniform. So how to identify the direction of the field? Depends on the current to the remaining portion. Okay? అరే కొంచెం పెన్స్ అట్లా ఉడికెత్తిపోతుందిరా హాట్. నాకు ఇచ్చే రిమోట్ మీకు ఇస్తే పాడు చేస్తా. 30 ఎందుకే వాకిట్లో కూర్చోవచ్చు కానీ. 25 పెడతాను మేడం. Right. Any doubts? So inside the cavity field is uniform, and it depends on the distance between the two centers. Whole center, the actual center of the cylinder. Any doubts? A very standard problem. Right. This is also a very standard problem, very repeated problem. Yes, your time starts now. Your time starts now. Make it fast. Mostly An infinitely long wire lying along z axis carries a current. అక్కడ మన దానిలో ఉంటుంది చూడండి, ఈ క్వశ్చన్ ఉంది. Infinitely long wire lying along the z axis. Can you see the wire? Here is a wire. Here is a wire. There is no other current. Consider a circle in XY plane with the center at 2, 0, 0 and radius 1 meter. Divide the circle in a small segment and then denote the length of the segment in anti-clockwise direction as shown. The path integral B bar dot DL bar of the total magnetic field B bar along the perimeter of the given circle is. Everyone can answer this. Why it is 0? No, first of all, it is not enclosing any current. Adi, you have only one current carrying source and that too outside. So therefore, according to Ampere's law, integral P bar dot DL bar is equal to mu naught times I enclosed, which is equal to 0. So therefore, B is 0. No, not B is 0. Integral B bar dot DL bar 0. B may not be 0 at any point. Till this point, any doubt? Next, consider 2 points, A3, 0, 0. That is this point. Right, this is A. B2, 1, 0, which means this point. B. You want integral A to B, right? Okay, no issues. Don't say 0 for this. Wrong. Right, because it is not a full circle. తెలివిగా చేయాలి క్వశ్చన్, జాగ్రత్తగా చూడండి అంతా. X axis, this is A, B, will take C for example. Remember, this is your origin where you have an outward current carrying conductor. And here is the point A. And here is the point B. నేను ఒకటే ఒక మాట ఏమడుగుతానంటే, ఈ డిస్టెన్స్ 1 యూనిట్, ఈ డిస్టెన్స్ 2 యూనిట్స్, ఈ డిస్టెన్స్ అంతరా √5. బాగా గుర్తుపెట్టుకోండి, నేను ఎలా వెళ్తాను అంటే రూట్, నువ్వు అడిగినది యాక్చువల్గా సర్క్యులర్ ట్రాక్ యాక్చువల్గా A to B. రైట్, నేను యాక్చువల్గా ఏం చెప్తానంటే, అసలు OA రేడియస్గా తీసుకొని, OAని రేడియస్గా తీసుకొని, లేదా మీ ఇష్టం ఎలా చేసుకున్నా పర్లా, లేదా OBని OB అంటే ఇది OBని రేడియస్గా తీసుకొని నేను ఒక సర్క్యులర్ ఆర్క్ తీసుకున్నా, నా ఇష్టం, ఇలా వెళ్తాను, మళ్ళీ ఇలా వెళ్తాను, నీవు అడిగిన పాత్రలో వెళ్తాను. దీని కొత్త పేరు డి. హియర్ OB ఈస్ OD. ఓకే, మీరు నోటీస్ చేస్తే along OB magnetic field, B magnetic field is perpendicular. Yes or no? So therefore, all that is perpendicular. Right. Now I know integral O to B. plus integral B to D plus integral D to A is mu naught. What is the I enclosed? Simple. You need to know this angle phi. అరే ఇప్పుడు 2π యాంగిల్ అయ్యి ఉంటే it will enclose current I. For phi angle, how much current is enclosed? Phi by 2π times I. Okay, since it is outward, no issues. But the problem is you traversed that in anti-clockwise sense, a clockwise sense. This is an outward current carrying conductor. So therefore, you will get this term as minus. I don't want to confuse you. I'll repeat everything once again. Just please follow carefully. See, when you are going in anti-clockwise sense, outward current carrying conductor is taken as positive. But if we are traveling in clockwise sense, outward current carrying conductor will become negative. Do you agree with this? Now also you find tan phi from here. Tan phi is nothing but 1 by 2. Okay, right. Don't forget that's the point which I want later. Now I am going along the path O to B plus B to D plus D to A is mu naught I enclosed. Clear? Anyway, this is 0 because along O to B, magnetic fields are perpendicular. Okay, next integral B to D B bar dot DL bar plus 0 is now mu naught times I enclosed 5 by 2 pi times I. Any doubt in this? Pakka? అది ఎవడని అడిగింది? ఇది ఎవడు అడిగాడు అసలు నేను? No one asked this. They asked actually A to B. Hold on, man. Now I will take this loop again. Now I will take this loop again. B to D plus B to D, D to A plus A to B is mu naught times I enclosed, which is 0. Okay, na? Okay. And by the way, in this part, B to D B bar dot DL bar plus 0. 0. Why it is 0? Hello, why it is 0? D to A, radius direction. Magnetic fields are perpendicular to that line. 0. Plus, actually you are supposed to find this. B bar dot DL bar is 0. So therefore, finally, A to B, B bar dot DL bar is minus of this. B to D, B bar dot DL bar. By the way, no one observed I should put a minus over here because I have clearly mentioned the reason here. This is the reason. So therefore, finally, this will become A to B, B bar dot DL bar is mu naught times 5 by 2 pi times I. Here phi is tan inverse 1 by 2. So therefore, what is the correct answer? Mu naught I by 2 pi tan inverse 1 by 2. Any doubts? Maximum value of hello. Post. వస్తాను. Right. Keep working on the 23rd. Right. Hurry, just keep this aside. So 23rd question, just see that the maximum value of the path integral of integral b bar dot dl bar, the total magnetic field b bar along the perimeter of the given circle between the 2 points on the circle. Where is the circle? No. The maximum value of the path integral b bar dot dl bar of the total magnetic field along the perimeter of the given circle between any 2 points on the circle is. That is the question. What exactly he wants? That is for our reference. Let me first of all try to analyze maximum value of b bar dot dl bar of the total magnetic field. Okay, నాకు అర్థమైంది, నేను చెప్తాను. Just see this. Because I want space for that question. If you can take this, this is your outward current carrying conductor, and here is your circle. You should do cleverly this problem. How? Nidhi, tangents కొడదాం చూడు. నేను ఆ క్వశ్చన్ చూడంగానే నేనేమన్నా కంగారు పడ్డానా? లేదు. నేనేమన్నా అసలు వాట్ ఈస్ హిస్ ఇంటెన్షన్ అనేది అడిగా. సో ఇప్పుడు దాని జడదు పోతే ఏమన్నా అయిపోతుందే, నాకు డిస్టర్బెన్స్గా ఉందే, నేను ఏమైనా పీకేస్తావేమో భయంగా ఉంది నాకు. నెక్స్ట్, ఇప్పుడు దిస్ ఈస్ ద సెంటర్ విచ్ ఈస్ ఎట్ ఎ డిస్టెన్స్ ఆఫ్ 2 meters. One meter. I think now you got idea. This is 2 meters and this is 1 meter. What is this angle going to be? 30 degrees. What is this angle going to be? 30 degrees. I got the point. Now in this circle, if you start from here, let this be some point A and let this be some point B. If you follow this path AB, hello, if you follow this path AB, remember I can construct another arc here. That's my arc. Okay. Now in this, can you see 2 paths? Path 1, path 2. For path 1, I know b bar dot dl bar. For path 2, they are expecting 0. Why 0, Nidhi? Because that particular loop is not enclosing any current. Okay. Confusion agadu. Gazulalo emo charge. Ekademo current. Right. Good. Here ikkada kana doubt unda? Right. 1 మనం చెప్పేచాము. యాంగిల్ ఎంత? 60. ఒరే 2π అయితే అయ్యి 60 అయితే 1/6. So therefore mu naught I by 6. By the way, you are coming in clockwise sense. Mu naught I by 6 plus b bar dot dl bar is equal to 0. Why minus? I told you very clearly here. Hello. If you are coming in clockwise and for outward current, I is negative. So therefore, integral V bar dot dl bar, a path to or A to B is mu naught I by 6. And this is the maximum. That is the maximum arc that your circle can intersect. Yes or no? So that is the maximum arc your circle can intersect. Excellent question, actually. Got the point? Sure? Right. Now we will move on to another. Anyway, you said you have done this. Right. I think you will simply do only one thing. No? What is that? Mu naught J by 2 times. Actually, the distance between them, A by 2. Right. Denominator, actually, you have 4. N by 12 is 1 by 4. N is equal to 3. Right. Right. Next. Now, the next immediate concept is, I'm now giving some theory again. With this theory, I will close this week's theory. Tomorrow onwards, we need to do work parallelly. Easy questions, you do. Difficult questions, I will work in the class. Tomorrow also, I will discuss not Pathfinder questions. I will discuss elementary level questions only. There, this one, are very simple, right? The center is A by 2. Just now we have given field is mu naught J T by 2. Mu naught J, D stands for A by 2 by 2. Mu naught J A by 4. Mu naught J A by 4. And you equate this to mu naught J A N mu naught J A by 12. At point, acha. No issues. No issues. I'll do this. At point P, I am assuming outward current. At point P, what is the expression for B? B1 is mu naught integral B1 into 2 pi A is mu naught times J into pi A square. So finally, what is that you are going to write? Mu naught J A by 2 down there. Right. That is due to full. Due to this, it is now inward. Due to inward left side, upwards. B2. By the way, what is B2? B2 times, from this center, it is at a distance of 3 pi A by 2. Mu naught 2 pi 3A by 2 is equal to mu naught times enclosed. J times pi A square by 4. Right or not? Area 2 cancel, pi cancel. So B is mu naught J A by 12. Any doubts? Pakka? Sure? Now the question is, this is B2. Net is B1 minus B2. Mu naught JA by 2 minus mu naught JA by 12. 6 by 2 jeste 6 by 12 minus 5 mu naught JA by 12. Let me just check this. What is this? Is the last question of Got that? Same way. 5 Hello. We got the same answer. Right. Any doubts? Any doubts on this? Right. Now we will work on the next concept. That concept is force between two parallel current carrying conductors, and on this you will have n number of applications. Remember, whenever you are doing a problem of electromagnetic induction, 30-40% of the content is supported from magnetics only. If you are weak in magnetics, you cannot do induction. That's the problem. So make sure that you do well in this. Right. Now here we have force between two parallel current carrying conductors. Right. Now imagine that you have a current carrying conductor I1, long straight current carrying conductor. And you have another long straight current carrying conductor carrying current in the same direction. They are long. Forget about your right side conductor for a while. Okay. Nidhi, due to the left red current carrying conductor, right side, what is going to be the direction of the field at every point? At every point, field will be inwards, 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 inwards. Throughout, it is inwards. Now again, don't get confused. Fleming's left-hand rule. Now put your pointing finger into the plane of the board. Set the central finger upwards. Now due to that field, this one will experience force. Now force is mu naught by 2 pi. Let this be separated by d distance. I1 by d. This is B. What is the formula for force experienced by a current? BIL, correct. I2 L. L stands for the length of the car, or whatever the length, it is length. But in general, we won't use this terminology. We will use F21 hereafter as force per unit length. This is called force per unit length. Clear? Now F21 can be written as mu naught by 2 pi I1 I2 by D. And what is the direction of this force? Leftwards. Similarly, you will experience force on 1 due to 2, force on 1 due to 2 as mu naught by 2 pi I1 I2 by D rightwards. So in this case, they are attractive. If the current is in the same direction, forces are attractive. Remember, whatever I am writing here, mu naught by 2 pi I1 I2 by D is force between two parallel current carrying conductors. Till this point, any doubt? If the forces are in opposite direction, for example, if the forces are in opposite direction, they will experience a repulsive force, but magnitude is still the same. Okay, this allows us to define 1 ampere. Okay, now 1 ampere is defined like this. Now you have a long straight current carrying conductor. You have another parallel current carrying conductor like this. Now they are separated by a distance d. Now the force is mu naught by 2 pi I1 I2 by t. Any doubt till this point, boys and girls? Now I am taking, let I1 is equal to I2 is equal to 1 ampere. Let d be 1 meter. And by substituting this, F becomes mu naught by 2 pi, which is nothing but uh, 2 into 10 to the power of minus 7 Newton per meter. Don't forget, it is not force. It is force per unit length. Okay. So what is 1 ampere? If two current carrying conductors separated by a distance of 1 meter, okay, if two current carrying conductors separated by a distance of 1 meter carrying identical currents, if experience an attraction force of 2 into 10 power minus 7 Newton per meter, then the current in each conductor is 1 ampere. That is the definition of 1 ampere. This is how 1 ampere is defined. Okay? Any doubts? Now, on the basis of this, now we will have questions. Now, let me start the first question. First question, you have this one. Right. This is the first question. Find the magnetic force on the square loop due to the current I1. Remember, try to please understand, this is I2, this is also I2. Now see the contribution of forces of B and C, let us analyze first. Now you take a very small element over here. Fleming's left hand rule. Hello. What is the direction of the field to the right side of I1 current carrying conductor? Into the plane of the paper. Nidhi, into the plane of the paper. Pointing finger into the plane of the paper. Central finger rightwards. Thumb is upwards. This is some DF1. Now you take a similar element over here. On this, the force is DF1 downwards. Correct or not? So therefore, F net of BC and AD is 0. Forget about that for a while. Now, if there is a force, that force is on this. This is FAB and this is FCD. Nidhi, why I have written rightwards on CD? Which are opposite direction. The main current carrying conductor I1 and the element CD carries current in opposite direction. So I have shown that opposite. Whereas the main current carrying conductor I1 and the current carrying conductor AB carrying current in the same direction. So there is attraction. So therefore, what is FAB? FAB is simply mu naught by 2 pi I1 I2 by A times A. Don't forget, this portion which you are seeing is force per unit length into A. Now what is FCD? Minus mu naught by 2 pi I1 I2 by 3A times A. So F net is mu naught by 2 pi I1 I2 1 minus 1 by 3. So what is this force finally? Okay, what is this force finally? Mu naught by 3 pi I1 I2. That is the force. And the net force is literally leftwards. This net force is leftwards. Means otherwise, as a whole, the coil is as a whole, the coil is moving leftwards. అరే ఇప్పుడు ఈ డౌట్ చెప్పు ఏమిటి? ఒక్క నిమిషం చెప్పు. ఎక్కడ ఈ స్టెప్ 3A ఎందుకు వచ్చింది? ఈ డిస్టెన్స్ 3A కదా. అదే అంటున్నా. మరి వాడు నన్ను అడగాలి కదరా. రైట్. ఎనీ డౌట్స్? క్లియర్? పక్కా? రైట్. విల్ స్టాప్ హియర్.